Hello students, welcome back to the spring semester 2021. This studio is Aesthetics, Geometry and Structures in Shell. The studio will be led by me, Urvi Sheth, co-tutored by Hrushikesh Patel. We will be assisted by Astha Shah, your TA and primary contact person, along with Keena Shah, who will be assisting on specific modules of the course. Let's start with the introduction of the course. As the name suggests, the studio is going to deal with shell structures. So what are shell structures? A shell is a structure defined by a curved surface. It is thin in the direction perpendicular to the surface, but there is no absolute rule as to how thin it has to be. It might be curved in two directions like a dome or a cooling tower, or it may be cylindrical and curved only in one direction. Shell structures are studied under the broader subject of surface structures. Surface structures include tensile structures, compression structures, cantilevers, etc. like sails, balloons and bolts. If one wanted to exclude tension structures, one might stipulate that shells have to work in both tension and compression. But how about masonry bolts that can only work in compression? Most people would describe masonry bolts as a type of shell structure. It is a vast subject where aesthetics and performance are woven together. Students would be required to design an application-based shell structure. For example, a residence, a restaurant, shopping area, museum, auditorium, cathedral, train station, drone port, airport, and so on. To aid to this process, the studio is divided into 5 modules. The first 2 modules involve learning from existing knowledge, and the other 3 are the application of this knowledge in your own design. The first module is understanding the surface structures and shells through case studies. Module 2 is the introduction of structural design through calculation method. Now, in module 3, you start designing your own project by form finding using computational methods. Module 4 would be an analysis of your generated design, followed by module 5, which is detailing and prototyping of the same. Let me give you further details of each module. In module 1, students will learn the theoretical framework of shells, highlighting the aesthetics, geometry and structural integration from case studies. Surface structures can be observed in the smallest form in nature to the largest form in man-made. Soap bubbles from nature and pantheon in man-made are the classic examples of these structures. To understand this subject at depth, input lectures on the same would be given by the tutors. Module 2 deals with traditional methods of structural calculations. Here, students will learn to calculate forces acting on simple shell structures like domes and cones. Module 3 is the beginning of design project. Students will start generating their own design project using digital models. Rhino and Rhino Volt would be used as design generating tools. The video shows basic workflow of Rhino Volt, where you first generate a base pattern. Then it is brought to horizontal and vertical equilibrium by the software. Following these steps, a compression only form is automatically generated by the software. The same workflow is also shown on the top. Please note that students are not required to have prior knowledge of the software. Rhino, Rhino Volt and StatPro will be taught during this course. In Module 4, structural analysis of the design will be done using StatPro. Students will transfer their designs from Rhino to StatPro without redoing them from scratch. Feedback from the analysis will be incorporated in developing the form, and students would have their final design of shell structure. Last but not the least, students will be encouraged to have a hands-on experience of making a concept model and scale prototypes. The video shows the process of making one such 1:20 scale prototype of Pompidou Mets, which is a timber grid shell. The final output from the studio would be as follows. The following video shows the process of making a concept model for your generated shell structure. At the end of the studio, the students would be required to have case studies, reports and models, form finding digital methods, their own generated shell, its concept model and details. Hope to see you in class. Thank you.